So,
easy.
I will take away your yeah.
Here, I'll be careful. I should put my leather jacket.
oh, nice. Okay, anyway.
Like, if you're gonna be like the leather jacket.
So,
Every day it's a
second
emo
block,
girl.
I think I might have ruined
I
it
think
in
I'd
one
run out of
class.
emo.
Well,
You might have.
Mr. Walters is gone, and they said, hey, can you sub for him? And they were doing like reactions.
Wait, today?
Yeah.
My sister's in there.
Really?
The second hour?
Yeah, I might have ripped her. Well, because I explained everything with Chihuahuas and St. Bernards. And,
Oh, they're gone.
yeah,
I looked over.
yeah. I said, all we're doing is rearranging the Chihuahuas, that's it. They're like, what? I said, that'll make sense later on. Okay, so speaking of rearranging Chihuahuas, I made a mistake when I typed up that list of what I typed up and had you to do. That decomposition, that should have been water, and I was in a hurry and typed, I think, H2, and then like a sad face, and then something like that, okay? Yeah, it's on the page that, the sheet of paper, the half sheet of paper that I gave you. That should have been water, not a smiley face, okay? So if you, and Nathan, bless his little heart, realized that I don't think we're gonna make liquid hydrogen gas. Because that would have been really cold. Because that's the second coldest liquid on Earth. The coldest liquid on Earth is liquid
Bro, I
helium.
can text you about that.
So,
I didn't the
probably
text
not
after I
liquid
left physics.
hydrogen. And the thermodynamic data for liquid hydrogen would have just been zero anyway because it's elemental form. So that should have been liquid water, my mistake. Okay, my bad. So when you look on like question number 43, okay, so let's talk about this. So it's handy, you all have seen this reaction, okay? So this is magnesium reacting with oxygen in the air, and you get magnesium oxide, and delta H is this huge number, negative 1,204 kilojoules. And you balance it, and you got 2, and you got 2. Okay? You burned magnesium ribbon. I've done it in this class. When you burn magnesium ribbon, it produces this brilliant, bright flash, and it's really hot. Okay? So basically what happens when you form this and you rearrange the Chihuahuas, and that's all that's happening, the Chihuahuas are way up here at this excited energy state, and they end up way down here, and they go, oh my God, we have to get down, and to do that, they give off all of this energy, which is this bright light, and it's very hot, and it's a very exothermic reaction. So here's what you need to do. So when you get to question B, and it says, calculate the amount of heat transferred with 3.55 grams of magnesium. So here's what you have to understand. This is per 1 mole of oxygen, or it's per 2 moles of MgO, or it's per 2 moles of magnesium. So when you do this stoich, and by stoich I mean not writing down random numbers, Colin. So start with the 3.55 grams of magnesium. Cool, molar mass of magnesium is 24.3 grams. That's 1 mole. So if you stop right now, what do you have?
Moles
Of
magnesium.
magnesium, right? Now, when you look at the data, you've got the 1,204. So down here, this is what you have to be careful of. So what that 1,204 kilojoules, that's per 2 moles of magnesium because there's a 2 in front of that. So the only time you would put 1 mole down there is if you were talking about the oxygen, because that has the coefficient of 1. So when you do this last step, you have to realize that that's based upon however that coefficient is in front of it. Okay? In this case, that would be per 2 moles of magnesium. If you're doing magnesium oxide, that would be 2 moles of magnesium oxide. Okay? That's the trickiest part of that. And so when this one, and don't get hung up on this, it says calculate the amount of heat transferred. It's just like an absolute value. You don't have to make it negative. It's just the amount of heat. Okay? That's all. So it's just an answer. All right. On 56, let's make sure everybody's cool on 56. Because this is what you've got to be able to do on the quiz today. Okay? So, literally this is called coffee cup calorimetry. Okay? Because you use coffee cups. Right?
Why error?
Styrofoam.
Because the styrofoam
Insulation.
trapped with that. So, is ammonium nitrate going to dissolve in the water?
Yeah.
Yes.
It's nitrate.
And it's ammonium. Okay, you could make this thing not dissolve if you tried. Right? So, you got the 6.5 grams. So, there's a couple of steps that you need to do. First off, you can calculate the Q value using M delta T C sub P. Right? The mass is the mass of the ammonium nitrate plus the water because it dissolved into it and became part of the system. So this mass that you're going to use on 56, that's the mass of the water and the mass of the ammonium nitrate. So that mass there needs to be 66.50 grams. Now, when you did this, what happened to the temperature of the water? It dropped. So right away, you have to understand that the water is the surrounding. So the temperature has dropped. That energy had to go somewhere. It's just like where to go. I don't know. It just disappeared.
No.
Okay? Right? I'm a wizard. I made it cool down. Okay? There you go.
There you
Yeah,
go.
frozen. What was the guy's name?
Hans.
That was the
Frozen.
I would
reindeer.
have Christoph, Hans, Sven.
Finn was the reindeer.
Steven.
Yeah,
Describe
yeah.
it.
No, the guy.
The ice dude?
Yeah, the ice dude.
Christoph.
Christoph. Okay. Call me. Just don't call me.
So,
So, from the thermodynamic standpoint, the energy had to go somewhere. So it either went to break bonds or it went to form bonds. So the energy went somewhere. So remember this, remember this, remember this. To break bonds, you have to put energy in or take energy out. In. Okay? It's like here. This, I'm going to break the bonds and hold this hydrogen to this nitrogen. I got to put energy in to break it apart. Now, when you reform the bonds, oh, you hear that, okay? It made noise. Formation of the bonds releases energy. So what this tells you is that the energy that you had to put in to break the bonds and hold the ammonium nitrate together was more than the energy that was released when the ammonium nitrate bonded with the water. So you had two things involved. You had to break the bonds and hold the ammonium nitrate together, and then when it attached to the water, that formed bonds, but that released some energy. But you know, because the temperature went down, you put more energy in to break the bonds than the energy that was released in the formation of the bond. So when you calculate Q, your delta T, is that going to be a positive number or a negative number? That's going to be a big negative number. So what's going to be the sign of Q for the surroundings? Negative. So this is how much energy that was lost by the water, which went into the system. So when you do the Q for the system, what do you do with the sign? Make that a positive Q. And then what do you divide that by? Moles of the ammonium nitrate. Okay? Moles of the ammonium nitrate. So your answer to 56 should be around, this is an ish, around 25.
27.13.
Nah, 26.7.
I'm more of a 26.7.
I was 26.6.
It's probably more.
Okay. Anyway, with that said. Oh, your answer to 78, and so help me, you be very careful how you respond to this question. Your answer to 78 should be around my age in kilojoules.
Wait.
Big Mike, I swear to God.
I'm sorry. Hey, I'm sorry.
Hey, I'm running the money. I don't know what it is.
But like, negative.
Yeah, how are you looking at me?
Yeah.
I'm immortal.
Wait, is it not
I'm a
supposed to
time traveler.
Oh, Bert, this looks like double your age.
There's no way they're over 35.
I got it. I was playing more like my life.
Hey,
It's funny.
I need my pen over.
Okay.
But seriously, Bert, what's the secrets? Like, what are the secrets?
Shut up, Nathan. Alright, we're done.
Alkaline water.
Yeah, no, that's not
Give me
it.
your
All the questions that I gave you where you had to assign that positive and negative delta H's, okay? The vast majority of your answers should be positive.
Like,
On what?
5%?
I'm just saying.
Well, he says the vast majority.
So like 75%.
I keep typing these.
Yeah.
Well, it's either 25, 50, 75, or
We literally
100.
have the same numbers. What if we
So-
can't type numbers in like
You figure it out.
Do you want this?
What, Big Mike? You don't have to say it with a little paper to
If
it.
you just like have
Almost
this,
0.6.
use this instead of like NaOH for titrating, could we like invest in alkaline water instead of
But,
using
but here's,
NaOH?
you don't know what's creating necessarily the hydroxide. That's why you wouldn't want to use it.
Well, let's look at the ingredients.
This is water.
It says
Wait,
water.
wait, ingredients list: purified water, potassium hydroxide,
Ooh,
calcium chloride, magnesium chloride.
hydroxide stuff.
You think those chlorides are?
So we could titrate it with hydrochloric acid.
That'd be kind of cool.
You know.
That's
We
Figure out the
figure out-
molarity of the hydroxide.
Oh,
There
there you go.
Too late.
All right, going once, go twice. All done? Okay, just put it all up there at that top. All right, see you.
I got it.